Welcome to another episode of Dominic Does DIY. As always, like, subscribe, and comment down below if you find this entertaining or useful. Also, if there's something you would like to see or explained, let me know in the comments down below. So today I'm going to do something a little different. Since this is my YouTube channel is a side thing that I just try to do on the weekends. I also have other stuff I got to do. I don't have tons of time. So I wanted to work on a project, and I figured I would show you all. And if you can get some use out of it, then great. Basically what it is I own a 1978 Chevy C10. It's my work truck, to say the least. So that's it right there. It's not pretty, but it does what I need it to do. I do a lot of work at home where I do some construction. I'm rebuilding the second floor, remodeling, right? And then I'll be doing the first floor. So this thing's a beast. It will do everything that I need it to do. But as such, it is a little sketchy to, like, it runs everything. It's got like a new engine, new transmission, suspension. Even though it's a C10, you can see the Scottsdale 10 right there. So it is a C10. But I've upgraded it. So it's got a 700 R4 transmission with a 300 horsepower, 350 crate engine, and 1-ton suspension on it. So I can go to a Home Depot, or I can go get tile or get whatever I need, and I can drop 2,500 pounds on there. The truck will drop maybe 2 inches, and I can still do 55 miles an hour on a freeway. If I go faster than that, I start skiing, but this thing is a work beast. So I really don't want to get rid of it. But there's some little quirks with it being as old as it is, right? One of those quirks is the speedometer doesn't quite work as well as I would like it to. It works, but the thing is when it works, it's about 5 or 10 miles off, sometimes, depending, right there. So you can see it's not even like really old paneling going on here, but the fuel gauge, it just flat out doesn't work. Like, it says E right there. It could be full. Like, I don't even know. This thing will just like bounce back and forth like this when I'm driving. You can see my ghetto tack going on right there. That's just zip tied to my steering column. And but the speedometer right here is basically, it just doesn't work. It's 6 to 10 miles off. The reason why it is off is because when I put the new transmission in, I went from a TH400 in there to a 700 R4. And when you do that, the way the speedometers work in the olden days, and maybe they still do now, I doubt it though, because everything's digital, but you have the speedo gear right here. And so basically you stick this thing into your transmission, and as the transmission's turning, that turns these gears here, which spins this wheel. This wheel then goes into your speedometer cable, and it just spins it a certain RPMs, and then your speedometer translates that into the speed that you are going. And what it is because everything is kind of squirrely with this old system. So even though all of these speedometers gear sets look the same, they're slightly different, either in the width or the size or something like that, in the diameter of here. And what it is depending on what transmission with what speedometer, what color you use. And so the problem with mine is I don't even have one of these colors in my car. Like, mine is a different color altogether. I can't even find the color, and none of these things actually give me the right speed. So I don't want to buy a new speedometer. I don't want to have to go through all that work. So what I'm going to do instead is I just want to make my own kind of digital speedometer thing, right? So what I'm going to do is I'm just going to get a TFT display. You can see that right here. This is the one I bought, 480 by 320 SPI serial interface. It uses the ILI 9488 module. So basically it's the same, pretty much the same chip as the ST7789 that you see all over the place. This one, the only difference between this one is, and I don't like it, but it's too late. I already bought it, so I'm not going to redo things or buy a different one. But the downside to this one, as opposed to ST7789, is the ST7789 can do 16-bit color codes, and this one actually does 18-bit. And so even though both of them use the 565 color scheme for bit mapping, this one requires 8 bits of transfer, which means it requires 3 bytes per pixel, where the ST7789, it can do the same thing with 2 bytes of data, because it can do 16-bit addressing rather than 18-bit addressing. That was the only thing that was really quirky about this one. I got this one mainly because it was touch pen compatible. It was touch compatible. So as I'm going on right now, I'm just trying to get a heads-up display for the speedometer and some little stuff that I can pull off the GPS. But eventually I want to make a full-on thing that I can utilize this touch screen with, right? So that's why I went with this one. So I want to use this screen in order to display pretty much my my speed, right? So how can I do that? I don't want to use the transmission because that gets all sketchy, and I don't need to be super accurate, right? Like, yeah, sure, it depends on, I could get speeding tickets and stuff like that, but I'm going to use something that's pretty much good enough for what I want to do, right? Because if it's good enough, it's good enough. So what I'm going to use is this GPS module right here. And the reason why is it's pretty much already set up, right? Like I've got the pins, it just does what it wants. This actually uses the, as you can see here, the Neo 6M U-Blocks module. And so just out of the box, it's going to communicate over UART at 9600 baud. So the GPRMC reference, well, data, it has all of this information in it that we can take advantage of. And so what I care about really is the time, where is it at? The speed over ground. Of course, it's in knots. And so naturally, if we want to put it in miles per hour, we just got to look for, go Google knots to miles per hour, and that'll be our multiplier here, but it is in knots. And course over ground. And of course, 0 and 360 are north, and east is 90, south is 180, and west would be 270. So you just got to, however accurate you want to make the system, you just got to divide that circle up into the degrees. I'm doing a full like north by northwest, right? Northwest, west by northwest, west. So I'm going to do like 10, 12, something like that, cardinal directions, and I'll probably get annoyed with it, and I'll probably change it to just like north, south, east, west, and maybe the northeast, northwest, southwest, southeast, and not do those intermediary ones. But right now I'm going to go all in and just do it all. And I'm also pulling out the date because why not? It's there. So I'm pulling the data. I'm not really going to display it right now. It is in my plan to display it. But right now what I really want to focus on is I just want to display those 3 things, right? I want to display the time so I know what time it is. So I don't have to look at my phone. And I want to know how fast I'm going, and I want to know what direction I'm going, right? And so I want to put all that into the display. So how am I going to go ahead and do this? I'm just going to use an Arduino Mega. The reason I'm using a Mega is because I'm lazy. I got enough pins on there to do it with an Uno, but the Uno only has one UART port, and if you want to multiplex that UART port, it just gets, I don't want to do that, right? So I'm making my life easy so I can still have output on the screen and still have a UART that I can communicate with the GPS. This thing, as you can see, right up here, it actually has 3 additional UARTs that you can mess with. So we will just use RxTX1 right here for the UART, and then I can still see the printout on the screen as I want it. And so, yeah, so we're going to use this guy. The other thing that we need to do is take a look at the display screen. So the display module itself, this SPI module, just some basic stuff, right? RGB 65K. standard issue stuff, right? TFT, like I said, it has that one. It's 480 by 320, 3.5 inch, 4-wire SPI, right? And then here are the pinouts. So like I said, I'm not using the touch right now. So these upper ones that are highlighted with the touch, I'm not too concerned about them right now. So what I'm concerned about are these ones right here. These bottom 9. These go to the screen. And this is the pinout, right? VCC, ground, chip select, reset, data or command, MOSI, clock, LED backlight, and MISO. The one thing about this thing is it is a 3.5 volt chip. So it does have a regulator. You can come in with the VCC right here, you see, and you can see that, oh, okay, I can feed it with 5 volts and it'll produce 3, but the chip itself runs off of 3.3. So what we need is a translator, because you can't run 5 volts to it. So the display, we cannot talk directly from the Arduino with it, because the Arduino is 5 volts and the display is 3.3 volt VCC. If we try to communicate over SPI at 5 volts, it just doesn't work. It's in one of the documents of the manual for the display. And so we need a logic converter, right? Just something to go from 5 volts to 3.3 volts. So I'm using this TXX dev board right here. And so basically the A side here is going to be our 3.3 side, and the B side here is going to be our Arduino 5 volt side. And just so you're aware, the B side has to be 5 volts. You can't choose to 5 volts on either side. You have to stick 5 volts on the B side because that's just the way that the chip works. If we go back, so the voltage translator, you can see here VCCA, VCCB, but you can see that their supply voltages. Just zoom in. So you can see that the B side is the only one that can actually take up to 5 volts. The A side is limited to 3.6 volts max. So I have to put the 3.3 volts on the A side and my Arduino on the B side, right? So when I first started out, I wired it up, the Arduino. I'm missing the modules here, but basically I was doing this. It got really messy, so I wanted to not do that and kind of clean it up a little bit. So what I did is I bought this Arduino Mega Shield, prototype shield, and cleaned it up a little bit. So I put everything soldered down to the board. I'm not showing my disgusting wiring job underneath. It was pretty nasty. But basically I connected up all the wires. How did I connect the wires? And basically here's the GPS module. Not basically, but here's the GPS module. I also put on here a BNO 055 module, and the translator chip is right here. There's the A, there's the B side. So the B side is going to the Arduino, and the A side, what it's actually doing is it's going to this 9-pin header up here. And so that 9-pin header, I made an adapter board for the display, so I can connect the display to this thing directly. And this is the GPS module. So now I've got this thing that's all wired up and kind of looking nice on the exterior, so it's a little neater package. And how did I wire it up? Well, here's right here. This is just, I use KiCad if you're wondering too. Here's the Arduino pinouts, and I just use the headers that would be for those parts. So it's just the Mega. You can see I listed them, MISO, MOSI, all this stuff. And then over here is our logic translator part. I didn't make real parts for them because they come on modules, so I just did the pinouts. So the logic translator is a 20-pin module, and these are the outputs, right? The logic translator, you got VB, B1, B2, B3, yada yada, down to ground. And on the VA side, you got VA, A1 through A8, and you got output enable. And so the output enable, we just pull high because I always just want it on, who cares? And my VB side is going to 5 volts, and my VA side is going to 3.3, and everything on the 3.3 side is going to go to my display. And so that's this connector right here. That's my display connector. And again, I'm not using those touch things. So all of the displays go to the A side of the translator, the B side of the translator then connects to my Arduino, which is over here. And the Mega, it has specific pins for SPI. Honestly, I haven't looked into if I can actually change these. Don't really care. Usually SPI, if it's good, it would have hardware SPI anyway, and so probably couldn't map it. So these are the SPI lines by default, and so I just use those ones. So I don't have to do anything tricky in the code. I can just load up the SPI, and then I use these digital pins for the controls, like the reset, because I just need some standard issue GPIO for things like LED backlight, the data or command, the reset, and the chip select. Well, the chip select's included in here. Yeah, but that's pretty much how I wired it up. So underneath this board is a bunch of ugly wiring that did this, that connected up those things, and it also connected up the other things, right? And then the GPS module also has the TX and RX. So the GPS module and the BNO 9-axis accelerometer chip go into the I2C lines. So those were the other things that got connected. So then with the display on that header, this is my little adapter. I just have this breadboard with some jumpers, and so that we can see the display there. So in the code, I don't want to go through too many details because you can kind of see all the different functions I have in here for everything. But basically, the gist of it is this. All those files, if you want me to go into it, make a comment down below, and I can go into details on how I did some of this stuff. I do write my own functions just so I can know how things operate. So like there's TFT, there's a built-in, there's not built-in, but there's libraries for TFT, there's libraries for the BNO 055, there's libraries for TFT, there's libraries for the GPS, you can use tiny GPS, right? They're all there, but I just like doing my own. That way I know how the chip is working and I can modify it how I need it. So a lot of these things do what you can get in libraries that exist already, and they probably do it a lot better than me. So I'm not really, if you want to know what I did, feel free to ask and I'll go over it. But otherwise, what I basically do is I'm just checking for the GPS data. So if any GPS data comes on the line, just go ahead and start encoding it. All this is doing is, because I read the UART by bytes, so all this is doing is adding the byte to the end of a string. If I reach the end of a string, and it knows this from the format, because if we go to the NEMA reference, I know that I'm at the end of a line on a carriage return or line feed. So I just look for that. When I see that, it's a full string, I parse it for the NEMA string, and just so I can show you, it parses here. And basically, if it's that, then start just stripping out all the data, right? Set the time, set the date, set the speed, set the course based on the data that we received. And then other than that, all this function is doing is it then gets the time, gets the latest data. The digits here, they're just checking to see if anything is new, right? Because like I said, it was slow to translate. And so I did not want to update entire strings. I wanted to update as little as possible. And so I had to check to see what changed. And so long as something changed, just change what changed, right? Update what's changed. Just leave, if it hasn't changed, don't mess with it. And so I do that for the time right there, hour, minute, second. I do that for the temperature. It's all the same thing. And I do that for the speed, right? Get speed, check the digits, and if there's new numbers, go ahead and update the screen, and I do the same for the course. Course looks a little different just because it's not a number that comes in, so I did something different there, but that's all I'm doing, right? I get the data, and if it's changed, then go ahead and update the thing. Okay, so now that's the gist of it. So what I want to do now is I'm just going to go into my car. I'm going to take it for a drive, and we're going to see how this thing, how well this thing works, right? See if it does give me the time, the miles per hour, and the course. Let's see how well it works. So can see, I'm doing about 35 miles an hour right now in the car, and you can see that the time is ticking away, and it's only updating what I need. You can actually see that flash you're seeing on the time is not anything to do with the camera. That's just like literally you can see it. The Arduino runs at like 4 megahertz, so the SPI is doing the best it can, but it's translating a lot of data, and that was the reason why I didn't like that one chip, the ILL chip, instead of the ST chip, ST7789. It's because I got to set 3 bytes per pixel, but you can see that it's updated the time like I want. As for miles per hour, I'm doing about 30 miles per hour right now, and so it's pretty much on the money. I'm doing a lot of braking and going, so the course over ground, speed over ground is getting a little upset. My course over ground is a little sketchy right now. I try to blank it out with a black box, but it doesn't seem to work. So let's see if I can do some speed changes here and see what'll happen. So I'm slowing down. I got about 30 right now, 25, 20, 15. All right, now I'm stopped. Yeah, that course is like really bad. You're actually living the test drive right now. I have not. This is the first time I've actually taken it out. So it's kind of interesting. I don't know why the course over ground isn't blacking out like it should. They should be replacing that entire backdrop with black, and then overriding that black with the letters. So here we go. Let's take a look. And so I just made a left turn, and so I'm doing like 20 miles an hour, 25, 30, 35, and that's pretty much the speed limit, down to 30. Can't go much faster. So I found a place I could go a little bit. Faster. So I'm doing about 45 right now, 46. I'm trying to hit the freeway up. If I can hit the freeway, I can go a little bit faster. We can check this thing out. Okay, I found the on-ramp to the freeway. So here we go. And so once I get on this freeway, I should be heading west. I believe. It's a giant circle. I think at this point I'm west. Let's see, I'm doing about 55 miles an hour right now. 60. About 62, 63, something like that. 65. So when I'm reading these numbers out, it's because I'm not paying attention to my phone. I'm hoping everything just kind of doesn't move. I'm at 70 now. So I'm just reading the numbers off of my speedometer as I'm driving. We'll find out. I'll actually find out if the speedometer is right when I get home and download the video and look at what I'm saying versus what I'm seeing. So we're doing about 60 now. But yeah. Well, that's all I got for you today. Thanks for making it to the end of this. If you did, it was a little bit longer than my usual ones, and it wasn't my usual puzzle. And so next week, hopefully I'll be able to get another puzzle going for you. It'll be a little bit shorter video. The puzzles are already shorter. But if you like these projects, let me know in the comments down below, and I'll just keep you up to speed on how this is going, because I'm going to be adding some stuff here and there. If you also want to see me wire up the truck, because basically the thing is the headlights are gone, and so, well, they're not gone, but they're sketchy, so I'm going to rewire the headlights. And the thing is I want to be able to get some feedback onto this display to let me know if the brights are on or off. So I'm going to be adding to this display a little bit to interact with those headlights so I can kind of see what's going on. So anyway, if you want to see more of that, or you want to say anything down in the comments, go right ahead. And once again, like, subscribe, share, and I'll see you next time. Thanks.